Yes. Now it's okay. Good. But you are only 3%, including myself. Earlier, there were 8. Yeah. Okay, Butala. Do you have this? Yeah, I can see only 2 students. Puta kata karanne. Yeah, you can respond. Me note එක තියෙනවනේ ඔය කට්ටියලා. The one I passed to you. Can you remember? I put this into the Google Classroom. Yes. So we need to look into this tutorial in the notes. Okay, we need to look into this tutorial in the notes because this is the time. I think it's the right time to look into this. Okay, it's the right time to look into this because you have learned about enthalpy a bit. Okay, you have learned about enthalpy a bit. Okay, you have learned about enthalpy a bit. And also you have learned about entropy as well. Okay, and also you have learned about internal energy term as well. Okay, so when it comes to internal energy and entropy, both are thermal energies. Okay, thermal energies, and enthalpy has, yeah, enthalpy has an addition of a term. Internal energy is U, enthalpy H is U plus the pressure times V. This is for 1 kg. Okay, for 1 kg. So both the units of H and V. So H and U. H and U units are kilojoule per kilogram. Okay. When you have the units for 1 kg per kg unit, we call it specific. Okay, specific is the verb. So you have specific H and specific U, or I would say specific H and specific U. Specific H means we call it specific enthalpy. Okay, enthalpy. And specific U means we call it specific internal energy. Okay, same way, if you think of specific entropy, this one we denote by small s, and this is, okay, the unit is kilojoule again per kilogram but here we have per Kelvin term as well. So you have to be very mindful on the units. Yeah. So kilojoule per kilogram, specific enthalpy, internal energy also kilojoule per kilogram. Then the PV term in U plus PV, the P times V term also, the unit is kilojoule per kilogram, and this has some very important concepts I have already shared with you. Okay. Yeah. Okay, Putana. Yeah. So those are the terms. Now, I'm preparing the background for your tutorial. That is what I'm doing first. Okay. In the tutorial, you have noticed that. In the tutorial, you have noticed that. Yes, tutorial 1, you are referring to steam tables. Okay, the steam tables. So I have a question. What is the purpose of learning steam tables? If it is just for passing the exam, I think that is not, the purpose is not that good enough. So what is the purpose of learning about steam tables? It's a very big question to you. Okay. The purpose of learning about steam tables, because in this tutorial you have steam tables. Yeah, these questions are to review or familiarize steam table. Familiarization. So this is the objective of this. Why? Why you need to familiarize this? Why? Puta, any answers? Any answers? Please tell me. Any answers? Just unmute and respond to the class. Okay, respond to the class. Please. Please.
To understand the properties of steam.
Yes, very good. To understand the properties of steam. Very good. And why do you need to understand the properties of steam? Why do you need to understand the properties of steam? Why? Why do you need to understand the properties of steam? Yes. I know you have the answers, even though it is something difficult to explain. Okay.
So there is some. There is some heat.
Yes. Have you heard about working fluids? Yeah. because we will put a very strong case for the purpose. Have you heard of working fluids? Some fluids are really working, you know. Example in thermal power generation, let's say steam or thermal power generation using steam, because the steam you can use for thermal power generation. Okay, steam thermal power generation. So you are using steam turbine and or steam turbines and even steam engines. Okay, so there may be a system or a cycle of this power plant, okay, or steam power plant, or let's say this is the steam power plant. Okay, so what really works, even though you are working in a power plant, what really working there is the steam, even in Noracholi power plant. There are so many engineers working there, so many technologies working there, but the steam makes the power generation. Okay, steam, high pressure, high temperature, packed with full of energy, goes to the turbine, drives the generators, fully loaded with the electrical appliances, machines and all, fully loaded with electrical load. Yeah, somehow you can see that power is delivered by steam. So you are creating the system, but what really works for power generation is steam. Okay, at the turbine, those are megawatts, you know, at the turbine, through the turbine, steam delivers the power to the generators and go back to the condenser. From the condenser, liquefied steam, liquefied water, high temperature, through the feed pump, go back to what? To the boiler. From the boiler, there again the energized, re-energized water becomes superheated steam, again go back to the steam turbine. So there are four major components. The burner, sorry, the boiler, yeah, it goes to the boiler, the turbine, the condenser and the feed pump. Four major components are there. Okay, so this steam sometimes superheated, sometimes wet. Okay, sometimes wet steam means saturated, there should be some moisture. Sometimes 100% water. Okay, and sometimes in two phase, passing through this closed circuit. Okay, and the steam change the state, change the energy levels, and the steam is the one perform this work of power generation. That's why we call steam is a working. Understand? Yeah. So if we don't understand working fluid very well, how you are going to deal with power plants? Not possible. And the first step of learning steam or the working fluid steam is to look into the thermodynamics properties of steam. Those are included in the steam table. So if you don't know how to read the steam table, how to get the data from the steam table, it is not possible for you to analyze the power plants. Okay, so this
We
is
can't
the
hear you
first
clearly.
step. Uta, yeah, please. Yeah, please, anything. So that's why it is very important to learn about the steam. Uta, can you all understand? What's the purpose of this tutorial? Yes,
Yes, sir.
very good. And there are other working fluids as well. Refrigerants. Refrigerants. Again, does a work in refrigeration cycles. Either to remove heat, we call refrigeration, or makes the thing cool, or even can be used to pump heat. Okay, refrigerant for cooling and also for heat pumping as refrigerators, refrigeration for refrigerating, or heat pump applications, okay, or heat pumps applications. So it is the refrigerant that works. So all the components in the refrigeration circuit, starting from any point, let's see, from the compression, then condensers, of course, if you start from the evaporator, compressors, condensers, and then through the metering device, so expansion valve, come back to the evaporator and go back to the compression, cycle repeats, and through this cycle, refrigerant passes through, not as a passenger, but as a really working fluid. Understand, Buddha? That's why. So there are other types of working fluids as well. Even the gas in an IC engine, once energized or once fired, this energy-packed gas starts expanding. Once expanding means it delivers mechanical energy. And later it can be transformed into even electrical or whatever the energy forms. But the immediate transformation is to mechanical. So you can see how important to have the sense of working. Okay. Now I have a question to you. Let's say if you are a doctor. Let's say if you are a doctor. Assume for a moment. Yeah. Chintan. Oh, thank you, Vita. Thank you. Let's assume for a moment that you are a doctor and you know well about heart. Okay, you know well about heart. And your knowledge of the heart should be for the functioning of the heart. Then, if you think of functioning of heart, can you think about the heart without the blood? Because heart pumps blood. So if you forget blood, what else remains for you to study? Only a dead heart. Studying dead heart. Okay, just to know the components, let's say from our technical words, components or parts. But to understand the function, you have to study the heart with the blood flow pumping. Okay, so working fluid is blood, remember, and the heart facilitates for that. So when the heart stops, the reason for the death is not the stopping of the heart, but stopping of the blood flow. You understand? Same way, if you need to study the compression, let's say refrigerant compressors. Okay, this is a very good point I'm sharing with you. Let's say the refrigerant compressors. If you have no idea about working fluid, do you think you can have a very complete knowledge about compressors? Not at all. Also turbines, let's say steam turbines. If no steam passes through, same like the heart, no blood flow means that turbine is dead at that point when there is no steam passing. So the turbine comes to life when the steam passing through that. So steam is the working fluid. So if you have no proper sense of this presence of working fluid in that equipment, how can you become a very good technologist? Or very good engineer, or very good innovator? Not possible. When turbine comes to your mind, it should be the turbine through which the steam passes through, if it's a steam turbine. If it's a gas turbine, it is not a word, but it's an equipment and it's functioning, and gas should pass through that. So your mind, your imagination, together with the working fluid and the turbine or the component. Understand? That's why your first point of thought should be right, should be correct. If not, it is very tough for you to pick up the technologies. Okay, and this steam table familiarization is your first step of learning thermodynamics technologies, because without having knowledge of working fluid, you cannot study the components. You cannot study the thermal functions, thermal processes, delivering power, or maybe perform cooling, or doing pumping of heat, or maybe other processes like boiling, condensation, heat transfer, heat exchangers, recoveries, then the propulsion, or whatever. Propulsion means a rocket propulsion, or what, anything, okay, you cannot do without having a good sense of working. Okay, that's why it is very important to join this class. Without joining class, for you, steam table is just like Devarak Chakra Chakra table. So you don't know the value of that. So when you come to the class, at least you will understand the value. Once you know the value, you know how to learn. So this assignment, you have to do it with a very good understanding. And this assignment for you to understand working fluid up to some levels. Of course, this is the first step. And step by step, when we deal with thermodynamics, you will learn this subject to the fullest. Okay. In no thermodynamics classes, I believe in Sri Lanka, provide this explanation to students other than this class. You believe me. Okay. So that's why we have a purpose to learn about the thermodynamics, and we have a purpose to do this tutorial. So don't copy from the others, because no point. Okay, no matter how high marks you are getting for this CA, if your exam results, let's say CA you get 100 marks, your exam you get 40 marks for the paper. Do you think I will give 100 for the CA? No. I will assure that your CA should be proportional to your knowledge. If your CA 100 by right, your exam you should get at least 80 plus. Then your CA is reasonable. From the exam, if you get 40 and CA 100, so we can guess that you did it with some others' help and with no understanding. So don't worry about the CA marks. I need you to do this by your own, understand very well, make sure and confirm that you have received the knowledge, you have gained the knowledge, and you confirm that by doing this. Okay, so 40 for the CA, 100 for the CA. Don't worry, your CA marks, final exams based on your performance in the exam paper. For the exam paper, I am very reasonable. I am just testing your understanding of the subject, and I will not give any difficult questions. Okay, so I will test how well you understand the subject. Okay, since from the beginning I mentioned that thermodynamics is not maths, so I know how to test the thermodynamics knowledge without maths. Okay, so you believe you will sure pass the exam with no issues, and you will get very good CA marks. So do this yourself. Okay, so that is the explanation and the background I have prepared for you. Okay, that's the explanation and the background I have prepared for you. So in your note, there may be, I believe there will be a tutorial like this in your note. I believe that's why I gave you the notes in advance for you to take a print. Okay, take a print and keep it handy with you, because that is very important. Okay, that is extremely important. Okay, that's why. So anyway, I will copy this steam table tutorial to the PowerPoint. Okay, to this PowerPoint for you to look into. Okay. And if possible, we will discuss a bit about this assignment. If you need some helping hand from me. Okay. Tutorial 1 is about steam tables. I got this from your note. Complete table 3 using steam tables. Insert a dash for irrelevant items and interpolate where necessary. Okay. Since you have the notes, you can do it. So this is the same tutorial, and this is the table 3. I will show you. Yes, this is the same table 3. So you need to fill this. Okay, you need to fill this. As I mentioned you earlier, the lecture sessions here, the sessions we are sharing here is a support to the note. And I'm not doing the note 100% because it is not necessary. You can do this. So I am providing you all the background preparations to make sure, to assure that you can do this. Okay, to assure that you can do this. So this is the table 3. This is the table 3. So this says that complete table 3 using steam tables. Okay, insert a dash for irrelevant items and interpolate where necessary. Okay, interpolate where necessary. We will see. This is the table 3. So this says that complete table 3 using steam tables. Insert a dash for irrelevant items. There can be irrelevant items. So then you insert a dash and interpolate where necessary. Interpolate where necessary means I believe you have the steam tables as well. Thermodynamics property tables, Rogers and Mayhem. Last time we managed to download. Okay, we managed to download. And you have noticed that Rogers and Mayhem property tables. Yes, this one. SI units. Yeah, you have seen this in the Zoom sessions. So wherever it's relevant, you have to look into the tables. Okay, got it. So you have to refer this and you have to answer, means you have to fill the table 3. That is your question number 1 of the tutorial. That's the question number 1 of the tutorial. Look into table 3. Okay. So if I refer table 3, you can see pressure column here in bars. Temperatures in degrees Celsius. Okay. Temperatures in degrees Celsius. You can see. Then you can see Vg. Vg means specific volume of gas. Okay. X, the dryness fraction. Degree of superheat. Specific enthalpies. Specific entropies. Okay. You have learned about U. You have learned about H. Degree of superheat. You have not learned, but it's in the notes. X, you have not learned, it's in the note. So all the other columns you will see as data in the steam property tables I have shown to you, and I'm very sure you also have the same. Okay. So let me save the presentation today. Dynamics 26 9 0. Okay. Very good. Good. Okay. What is this expital? Actually, when we learn in this Zoom mode, I cannot see you, you cannot see me, and there are only students by the way. And so many students are not here. But anyway, this is relevant for all. This is relevant for all. Those who are here, try your best to stick to this session without skipping. Yeah, that is very important. Yeah. So that's all. And then if you look into this unknown things, okay, if you look into this unknown things, what X means, okay, what superheat means, others would be known to you. Okay, so I'm going to share with you one unknown thing for you. That is, I will call the dryness fraction. That is what we call X here. The dryness fraction. What? Dryness fraction means it is not fully dry. Partially dried. That's why. Then of what? Wet steam. Okay. Dryness fraction of wet steam. I'm going to share this with you. Okay. Before that, again to prepare the background, if you go to your tutorial, see the question number 2. I think it is good to do question number 2 first, maybe when you do this. Okay, this is question number 2. Find the specific volume, specific enthalpy, and specific internal energy of wet steam at 18 bar and dryness fraction of 0.9. Okay, that's why. So this understanding dryness fraction is very important. Okay? Understanding dryness fraction is very important. So when you need to understand this, actually beneath this word dryness, beneath the word fraction, what really sends to you is opposite of dryness is what? Wet. Okay, so I add the word fraction also here. Okay, anyway, opposite of dryness is wet. So fraction means this is not fully dry. Okay, this is not fully dry. Partially dry means there is some wetness. Okay, wetness is there. That's why we call this wet steam, because this is not fully dry. See the wet steam term here in the question number 2. Find the specific volume, specific enthalpy, specific internal energy, not E but I, internal energy of wet steam at 18 bar, dryness fraction 0.9. Okay, so what x equals 0.9 means what? That's a question. X equals 0.9 means the dryness fraction x equals 0.9 means, okay, 0.9 means it is not fully dry but only 90% dry. Okay, so out of 1, 0.9 is dry. So the balance 0.1 is wet. Okay, so that is the 0.9 means out of 1, 0.9 dry. The balance 1 minus 0.9 equals 0.1 is wet. Okay, that's why dry and wet combined, we call it wet steam. Okay, is reasonable. Here, dry means I changed the word dry. Okay? Instead of putting dry, I put the word vapor or gas. But normally for steam, the vapor, the gas form of steam we call vapor. So I cut the word dry. Okay, instead of dry, I put vapor. The balance is wet means the balance 1.9. I mentioned instead of wet, okay, wet is not right term. I consider it as liquid. Liquid means water. The balance is what? Liquid means water. Okay, vapor means steam. But surprisingly, a steam, when it is not fully dried, we call this wet steam. Okay? But this is the wording how it is. Okay, this is the wording how it is. So that is we call the wet steam. Okay. Also, if you think of wet steam again, another knowledge for you. If you think of wet steam, this tells that, okay, this tells that not fully dried, not fully dried, okay, not fully dried means this is the water and steam, okay, instead of a steam, let's say vapor, mix. This is a water vapor mix, okay, water vapor mix. So even I take 0.9 is vapor. I just took the steam term out, okay. So 0.9 is vapor. The gaseous form of water we call the gaseous form of liquid. The gaseous form of liquid is vapor. So 0.9% there in the first case out of 1. The balance is liquid. So water and vapor mix. Okay. So very interesting these wordings. So now you know what it means. Okay. And for our case, so wet steam is this. Now let's say wet steam. I'm using the same here, wet steam with dryness fraction of 0.9. So this is what in your case. Okay, this is what in your case. Wet steam dryness fraction of 0.9. Now again, if you think it's quite okay, 0.9 out of 1 is vapor. Balance, that is 1, okay, 0.9 out of 1 is vapor. The balance, that is 1 minus 0.9, okay, again out of 1, that one also is liquid. Okay, so the vapor, we denote it with capital V here at the moment, and liquid we use L. So when you use LMV, L for the liquid and V for the vapor. Okay, so here 1 minus 0.9 is 0.1. Okay, out of 1 is Okay. I hope you can understand this. Please. And I have a question. What is this out of one means? What is this out of one means? ළමයි අහිනවද කියන එක? අහිනවද? පුතාලා අහිනවද? Yes, I hope you can hear me. But you know anything? Out of one means out of one what? Kg, kilograms, okay? Out of 1 kilograms. Out of 1 kilo. Out of 1 means out of 1 kg. So this is not about volume. This is about mass. Out of 1 unit mass. So here 1 unit mass in SI units. We call it, let's see, kilograms. Here it's 1 kilogram. You can understand? Yes. Okay, I believe you can understand this. Then, if I go to the next slide, this is your knowledge, piece of knowledge. I leave it here. ළමයි අහිනවද? ළමයි අහිනවද? I believe you can hear me something. Gulu, okay? I hope you also can hear me. So let's say, now I will take 1 kilogram. Okay. Before that, so one more knowledge for you. What is the extreme values of x? Extreme values of x. Extreme values means two end values, the minimum and the maximum. That is what we call extreme values. X equals 0 means, can you understand? X equals 0 means fully liquid. Interesting. X equals 1 means fully vapor. Fully vapor. And I need to explain it further. Okay? I need to explain this further. Okay? I need to explain this further. Fully liquid means the first tiny bubble of of vapor is about to form, which means this is at boiling temperature. Means liquid is at boiling temperature. the first tiny bubble of vapor is about to form, and the liquid is at its boiling temperature at the given pressure. Can you understand? Yes. So this is when x equals 0. If the liquid is not in boiling temperature, means there is no readiness for the first bubble to come out, then there is no relevancy for x equals 1. So, in other words, this is the readiness of liquid, thermodynamic readiness of liquid for its first bubble to escape. Okay, understand? Yes. So that's why it's in boiling temperature. So x equals 1 full vapor moves. Same way. Let me copy from this. See, what is this? The last, okay, tiny bubble of vapor is about to form. Okay. And, okay, tiny bubble is about to form means the last drop of liquid that is about to escape is at its boiling temperature at the given pressure. Okay, so here instead of the liquid for its first bubble to escape, here readiness of, okay. So here I won't say readiness. Readiness is there, but here is the last bubble is about to, yeah, readiness of liquid. So let's say the readiness here, liquids, last drop is about to escape or just escaped. It's about to form or just, okay, is about to form. Here x equals 0. Here we would say just form, not to say about. Vapor has just formed. Has just formed. Only it has vapor just. And the last drop of liquid evaporated was at its boiling temperature at the given pressure. Okay? And liquid's last drop is about, not to say about, just escaped. Okay, just escaped. So you are learning from here. You are learning from here. From x equals 0 to x equals 1. Okay, this wet steam, okay, x equals 0 to x equals 1, 1 kg, let's say 1, we will write this way. The temperature is the boiling temperature, or boiling point at the given. Temperature is the boiling point or boiling temperature. Okay? Boiling point or boiling temperature at the given pressure. Quite interesting. So 2 ends, x equals 0 at boiling point, vapor about to form, and x equals 1, again still at the boiling point, same pressure. Vapor is going to be fully dried and the last drop of liquid just added to the vapor phase. So two extremes, x equals 0, you know, x equals 1, you know. In between 0 and 1, there you will see a real dryness fraction where liquid and vapor remains together. Okay, I hope you can understand this explanation fully if you listen to what I have explained. Okay, Bhutana? Yeah. So this is a very good explanation I made to you about dryness. So let me move forward. Let me move forward further to give some helping hand on dryness fraction. 1 kg. Okay, 1 kg. 1 kg, the same 1 kg. Same 1 kg. Okay, so 1 kg, 1 kg, 1 kg. So here, example. Let's say x is 0.9 according to this question. Okay. We are there. Here, X is 0.0, fully liquid. Here, other end, X is 1. Okay, very interesting. X is 1. Okay, so temperature is the boiling point. H, pressure P. The same temperature is boiling point at pressure P, same. Here also temperature is boiling point at pressure P. But here only liquid. Okay. Here only vapor. Okay. Here you have liquid plus vapor. How? This one liquid is 0.1 liquid out of 1 and vapor 0.9. Okay, 0.9. So if this is 1 kg, only liquid 1 kg, only vapor, the rightmost 1 kg, last drop of liquid just evaporated, and liquid is 0.1 kg, vapor is 0.9 kg. Okay, Vidana, I hope you can understand this very well. Yeah, good. So when you have this basic understanding, you can answer this question. So if you go to the steam table, the example this, let's say 18 bar is the bar column, saturated water and steam. So instead of steam, they use the word, sorry, instead of vapor, they use the word steam because water vapor we call steam. Okay, 18 bar. This is your 18 bar. Can you see? This is your 18 bar. Quite interesting. 18 bar. So you can have all the values here. Internal energy of water means F means liquid, G means vapor. Enthalpy of water, HF, vapor, Hg. Entropy of water, SF, vapor, Hg. All at the boiling point. So at pressure 18, this internal energy is of liquid that is about to evaporate. That's why temperature 207 is the boiling point at 18. Okay. Now, by using this data, you can get the values. Example, if I look into this, back to the presentation here. U value of this. U value is U value of the vapor. Mix simple U means for 1 kg, okay, is you have 0.1 kg of liquid. So times UF, okay, times UF. So you will get the liquid portion, liquid portions internal energy component plus the vapor component is 0.9. The gas G is there. You can get this from the steam chamber. Okay. And now I'm writing the generalized form. 0.9 is, let's see, 0.9 is X. Okay, instead of times I put dot. Okay, dot is nice. 1 times UF. X times UG, and 0.1 means 1 minus X times. This is quite generalized, simplified. Okay. You look into the table, it's a matter of substituting the values. For V, because it's a mix, specific volume, so liquid, F, vapor, Hg. When it comes to enthalpy, it's the same, H, HF, Hg. When it comes to entropy, S, SF, Sg. This is quite easy. Further, this one I will write this way. See, 9, 0.1. I use 1 minus 0.9. That is how the 0.1, because 0.9 is there. 0.9, the balance is 1 minus 0.9. Okay, so you can really rewrite this if you need in this way. Okay. UF plus X. UG minus UF. Quite interesting. Same way. Here you can write VF plus X, VG minus VF. What is VF value by the way? What is VF value? Because VF is not in the table. VF is not in the table because of simply one reason. VF is generally well known. Right? VF. Liquid per kg volume in meter cube. So well known. VF. So here HF plus Hg minus HF. Okay. For this case, SF plus Sg minus SF. Very interesting. So this one you can write instead of Ug minus Uf, you can write this as UFG. UF plus X UFG. Okay. Let me put the bracket for your convenience. So VF plus X VFG. If you need a VFG, you can have it. Yeah. HF plus X HFG. You can have it. SF plus X SFG. You can have it. Because this SFG convenience of this, if you look into your steam table, let me show you. Can you see SFG here? Yes, it's there. Can you see HFG here? Yes. So these are there itself because of this convenience. So UFG is not there, but you can take it if you need it. Okay. So that's all for today. So superheat means you have to look into what superheat. Look into the notes. Okay. Look into the notes and you study that and try to understand what superheat. And you have to have some practical sense of that superheat. Superheat means, let's say, from the state 1, x equals 0 to x equals 1, we made it by heating, adding heat to this 1 kg. If you add some more heat, okay, if you add some more heat, let's see, duplicate this. Yeah. I need this more. Words are also small. And if you add some more heat, then X has no relevance. So if you add some more heat, X has no relevance. So then what happens is this one moves to a separate region we call superheated regions. Your temperature will rise. Example, here temperature, let's say from here to here, temperature you may have, let's say, here to here, that's the temperature. So temperature equals boiling point at 18 bar for this case. That is according to the table for 18 bar. It is 207.1. In the table, I will show you. See, in the table 207.1. Okay, you can see this 207.1. Okay, you can see that 207.1. 207.1 degrees Celsius. But beyond this, here what happens is when you move beyond this point, x equals 1. So no more relevancy of x. Okay, no more relevancy of x, and temperature starts rising. Okay, temperature starts rising. So your T will be very interesting. T is above the boiling point at 18 bar, means 207.1 C, more than that, so plus plus plus. So depending on the heat levels, this goes up. Okay, depending on the heat level. So example, let's say 200. Okay, 18 bar, you have 200 degrees Celsius. Now, sorry, 207 here, let's say 300 here. 307, let's say 300. So your temperature is 300 degrees Celsius. Example. So your superheat is degree of superheat is what? This 300 minus the boiling temperature at 80. Yes, this is the value. This is 29 292.9, maybe. 9 degrees. Right. So not 292. This is 92. See. Yes, good. 92. This is what we call the close. So I've shared with you what degree of superheating. So if you look into for this case, if you imagine for 300 degrees 18 bar, you have to look into the superheated table. This all saturated. Superheated is here. Superheated steam. 18 bar as well. Yeah, you have 15 and 20. So in between is 18. So that's why 18 and 200 is 300 is here. See 300 and 18 is here. So your values are somewhere in between. Sorry. 15 and 20 in between 15 and 20. So get this set of values and do the interpolation. At 15 you have values. What is this? Vg value. Sorry, V value is here. U value is here. Okay. Let me do a snapshot. Okay. Yes. So for the right side, you have to work on this. For the left side, you can work on this. This is for left side. You have X value when or X relevance is here. X relevance is here. But for the right side, you have to use this. This is at 300 superheat. So you have the V values UHS. VUHS at 20 at 15. So you have to do interpolation. At 15 this, at 20 this. So you have to do a graph here. Graph. Let me do a small one for you. For this case, graph. And insert the point. At 15, you have this value. Okay. At 20, you have this value. So you have the line here. So based on this, at 18, somewhere here, so you know how to get the graph. So the gradient, this is something like little bit. The school value, school level interpolation, you can do it. Even interpolation or extrapolation. Because at 15, you know 15 bar, you know, 15. Then at 20, you know, 20 is this. And at 80, you 18. Then you can find. So 18 you have to find. Interesting. Okay. 15, 18, and 20. 16, 15. So do the necessary interpolations and do the tutorial and submit it to me via email. Anyway, I will upload this to the Google Classroom. So that's all. Kita, any question? Lamai? Okay. ප්‍රශ්න තියෙනවද? අද ළමයි අඩු මොකද? හා? අඩු මොකද? එතකොට why only few students? Why only few students?
So some are at working.
Bogota?
Some students are working today.
Working today. Huh?
It's job.
Okay, working today, that's fine. Yeah? Anyway, of course you have to work. But,
Yes, sir.
it's okay, I cannot ask not to work. Of course, today it is justifiable. And maybe you can do one thing, since we do the lectures online, can you look for some flexible timing that most of the students can attend the lectures? So anyway, you are not hard. That only the PowerPoint presentation. Do you need the presentation file? Do you need the presentation file today?
Yes, sir.
Okay. So now I'm going to email you. I'm going to email you the presentation file. Of course, attach the documents. So do you need the steam table? Steam table එකක් ඕනේ.
Yes, sir.
That one also you need.
Thank you.
Let me add the steam table also. Stop. Property tables. Okay. What else? Today lecture property tables. Yeah. And do you need the lecture notes? Again, One of the lecture note take up who that. Huh? See, notice? So you have to look for that. You have to look for that. This object is assignment 1. So the C here is dynamics and today notes. Today notes 2. UVT NV2. Okay. Kita බලන්න ආවද කියලා. අවුලනවා කියලා කියන්නේ.
Google Classroom එකට දැම්මේ නැත්නම්
හම්බුනේ පුතා?
Gmail එකද Google Classroom එකට දැම්මද?
ඊමේල් එකට දැම්මේ. ඊමේල් එකට ආවද? You got it? හම්බුනේ. හරිනේ පුතා? Okay. ආවද?
I will check, sir.
Okay, you check it, you check it. So that's all for today. So let me stop the class now. So do your studies. I would say it is very important to do your studies in very meaningful ways. Yeah, then you will feel to attend the lectures. Yeah, try to receive the knowledge in very meaningful and very useful ways. And don't miss the sessions in a way that is very important. But you should not compromise your job also. You have to carry on the job. Yeah, that's all. So anyway, strike a very good balance between your job and the studies. And you cannot put secondary the job. Even you cannot put you cannot do the secondary treatment for the course as well. So try to balance it. Yeah. So that's all Buddha today. So let me stop the class. Good day, good luck to you all.
Excuse me.
Okay, sir.
Bye. Bye.